Problem number 24. We have 1 minus cosine of theta over sine of theta. And this is equal to square root of 3 over 3. What we are looking for here is we are looking for the general formula, or general solutions. We're looking for general solutions. We look at general solutions, we're trying to solve these equations. We have to take a look at the right-hand side. How can I take that back to my left-hand side? Which one of my half-angle formulas looks like 1 minus cosine theta over sine theta? Right? Tangent. So we have the tangent of theta over 2 is equal to square root of 3 over 3. Once again, this is very similar types of problems that we did with angle addition. Similar types of problems we did with double angles. We look at the right-hand side. How can I take the right-hand side and condense it back to my left-hand side? What does this look like? If I have 1 minus cosine theta, what does that look like on the other side? Okay, it looks like tangent half theta. Well, now I have an equation. Hopefully I can solve. What's the next thing I do, Isaac? Wagner? Plug numbers in? I want to solve for theta. How do we solve for theta in all these problems? Inverse tangent. So we're going to take the inverse tangent. So we're left with theta over 2 is equal to the inverse tangent of square root of 3 over 3. Make sure you quantify that. Just don't take the inverse tangent of square root of 3 and then divide that by 3. You want to take this inverse tangent of square root of 3 divided by 3 and end your quantity. Now some of you, your calculator will throw a parenthesis there. You have to close that out and then divide by the value of 3. Make sure you close that out. The other ones will have to hit your right arrow button to get that out of the get it out of the radical. Okay, I don't like that feature, but it's there. Inevitably, what I would have is I would add square root of 3 divided by 3, and then close the parenthesis out, and then I get value of 45, which is incorrect. Square root of 3 over 3, inverse tangent, what did we come up with, Emma? 30 degrees. So we have 30. Okay, we have theta divided by 2. How do I get rid of that division by 2, Trenton?
Multiply by 2.
Multiply by 2. By 2. So we have theta is equal to 60 plus or minus the period n. Well, the b value here is 1/2. How we deal with tangent? Once again, the period is 180 divided by a half. Sine and cosine is 360 divided by half. One tangent, we have 180 divided by half. Once again, this is the exact same thing that we did with angle addition formulas. So the period would be 360n. So we have plus or minus 360n. Didn't know we were supposed to get snow today.
There's some spares.
How's
I
it?
don't know how they're gonna stick.
Huh?
I don't know how they're gonna stick. But I put blue tape in the empty rooms.
Okay, that's fine.
We'll save these in case something comes up.
Alright, well, thank you. Do you need any over at the middle school?
Ask Amy.
I mean, if you want, if there's extras here and you need them over at the middle school, you
You
can.
may wanna hold on to them.
Yeah,
I'm just a little
Yeah.
hesitant on how they're sticking.
okay, that's fine. Any other questions? Once again, if you would follow along in the example problem we did in our notes yesterday. Each one of our trig functions here, they give you the cosine, it's some sort of version of 3/5. Some sort of version of 3/5. So you're plugging in the exact same value just like we did yesterday in class. Questions? Anything? Alright, this is a happy day because this is the last of the notes for formulas. Did I get everybody? We're in different seats. I need to take a picture of it real quick just in case. Okay, we're going to deal with sums and products formulas. Sums and products. There's 8 of these. 8 of them. You'll be asked to prove one of these, top 4, and it's an easy proof to do. Now, what we have to remember is what is meant by a sum and a product. A sum means we are adding 2 things together. It's a result of the addition of 2 values. A product means we are multiplying values. You will be asked to prove one of these top 4, and we'll go through one proof here. We have the sine of a plus b plus the sine of a minus b, and we want to show this is equal to 2 sine a times the cosine of b. Well, what I want you to expand out, look at your angle addition formulas. What is the sine of a plus b? Plus the sine of a minus b. Just expand out. Sine of a plus b. Write it out. You should look at your formula sheet there. If you look at your formula sheet, what is the sine of a plus b? Okay, your identity sheet that you should have written out that you used in the last quiz. Sine of a plus b. Plus the sine of a minus b. This is going to be a very easy trig identity. Because all you're doing is you're copying what is the sine of a plus b and the sine of a minus b. Or the cosine of a plus b, cosine of a minus b. You're just copying it out. Sine of a plus b is sine a cosine b plus cosine a sine b. Cosine of a minus b is, sine a minus b is sine a cosine b minus cosine a sine b. Okay, I asked you to do is write out the sine and sine of a plus b and sine of a minus b. That's your first step. Now let's take a look at what we have there. Do we have any terms that cancel out? Do I have identical terms that cancel out? John?
Cosine A and sine B.
Yeah, these second terms right here. This is a plus cosine A sine B. This is a minus cosine A sine B. They cancel out. Well, my other 2 terms, is sine A cosine B plus another sine A cosine B. So when I add them together, Aubrey, what do you get?
You get 2 sine A times 2 cosine B.
Nah, not times 2. Just if I had xy plus another xy, that would give us what?
2xy.
2xy. So if I have a sine A cosine B plus another sine A cosine B, that would give me what?
Would be 2 sine A and cosine B.
Cosine B. We is done. So you will be asked to prove one of these formulas here. You're going to expand out using your angle addition formulas. 2 terms will cancel out, 2 terms will be able to combine. What I have here is the other 3 combinations. Sine A cosine B, sine A sine B, or sine A plus B minus sine A minus B. This will simplify into 2 cosine A sine B. If I'm dealing with all cosines, cosine A plus B plus cosine A minus B. That turns into 2 cosine A cosine B. And the last one, cosine A cosine B minus cosine A minus B, turns into negative 2 sine A cosine B. If we take a look at the left-hand side, all these left-hand sides, you have sums and differences over here. Over here, you have all multiplication, so you have products over here. So we have products over here, and here we have sums and differences. So if we take a look at the equal sign, or just sort of space out, could you go back? There we go, one more. There we go. We're trying to space out a little bit more. We have a bunch of empty spaces over here. We're trying to fill them. If we take a look on the left-hand side, we have sums and differences. On the right-hand side, we have products. Yep. Go ahead. So we have products on one side and sums and differences on the other. Once again, these are all things that you're going to add to your formula sheet. And if we continue on down here towards the bottom, what we have here is a sine of x plus a sine of y, sine of x minus sine of y, cosine x plus cosine y. So we still have sums and differences on the left-hand side. So this extends on. And we look at the right-hand side, we have products over here. So on the left-hand side, we have all these sums and differences. On the right-hand side, we have all these products. Once again, the last 8 things that you can add to your identity sheet. All we're going to worry about is applications and solving equations with them. want to solve this equation. Sine 5 theta minus sine 3 theta is equal to 0. If I gave you the equation x squared plus 2x minus 3 equal to 0 and asked you to solve this, solve for x. How would we solve for x? Once again, this is algebraic skills. I'm trying to take you back into things that you're more comfortable with. Algebraic skills. How do I solve x squared plus 2x minus 3 equal to 0? If I add 3 to both sides, that just gives me x squared plus 2x equals a 3. Does not do anything for us. What do we have to do to transform this equation into something that we can utilize to solve it? Talking algebra here. Nobody remembers as the crickets sound. Yeah.
What do you have to put it in the FOIL form? Like x minus 1 and then x minus 2?
I'll take the x and x, but the values that you had there are not are not correct. What would be the two factors? 3 and negative 1. Plus 3 and minus 1. Whoopsie. We've transformed it into a multiplication problem. Why do we transform this into a multiplication problem? Because what we utilize at this point is what is called the multiplication property of 0. Multiplication property of 0. If things are being multiplied together equals 0, one of those things must equal 0. So we're going to use the multiplication property of 0. So x plus 3 could equal 0, or x minus 1 could equal 0. So x equals negative 3, x is equal to 1. But we have to transform it into a multiplication problem to be able to solve the problem. Because if we don't transform it into a multiplication problem, we cannot use the multiplication property of 0. So our goal when we have additions here is change it into multiplication. Okay, we factored down the quadratic equation. Okay, we undid the FOIL aspect of it. We got two factors that we can multiply together to equal what we had originally. Well, why did I go to that process and that process? Because that's the exact same thing we have to do with this equation. Because up here we had sums and differences. We changed it into multiplications. Here we have a difference. We need to change this into a multiplication. So I need to scan my list. Okay, I need to scan my list. Do I have a formula that takes sine of x minus the sine of y and transform it into something? Do we find one there? Sine of x minus sine of y. We're looking at the left-hand side. Okay, do you have anything? Yeah. What is it?
2 cosine x plus y over 2 sine x minus y.
That's correct. Here's my x and here's my y. So what I want to do is I want to rewrite this. 2 times the cosine of x plus y, but x is a value of 5 theta, plus y, which is 3 theta, divided by 2, times the sine of 5 theta minus 3 theta, divided by 2. What this put us into is a multiplication problem. If I have a multiplication problem, I can now use my multiplication property of 0. Can I find what 5 theta plus 3 theta divided by 2 is? Can I make that calculation? Mason, what is it? What's 5 theta plus 3 theta divided by 2? 4 theta. So we have 2 times the cosine of 4 theta times the sine. Well, what's 5 theta minus 3 theta divided by 2? Bennett?
Or, what'd you say?
5 theta minus 3 theta divided by 2.
Oh, whoops. 1 theta.
1 theta. Just gives me theta. Is equal to 0. I've now transferred this into an equation of things being multiplied together to equal 0. Just like I did up here with the quadratic equation. This quadratic equation, I couldn't solve it when it looked like this. I could solve it when it looks like this. This I can't solve when it looks like this. This I can now solve. Why? I can set each factor equal to 0. Well, 2 could equal 0. Cosine of 4 theta could equal 0. Sine of 2 theta could equal 0. I'm sorry, sine of theta, my bad. Sine of theta could equal 0. What I did, I went from here to here to here. Okay? I've gone from this to this to this. Can 2 ever equal 0? If you say yes, give me $2, I give you $0, we call that even then. Cosine of 4 theta is equal to 0. I want to solve for theta. Well, you get rid of cosine. What do I do to get rid of cosine? Inverse cosine. Now we're into things that we've done already. So we have 4 theta is equal to inverse cosine of 0. Turned into a clicky-clack exercise. Lexi, what do you get? 90. Or, take the inverse cosine. What do we remember what to do? Inverse cosine, we took the calculated value, which was the principal value, and it's what? Opposite. Inverse cosine was the opposite. So we have negative 90. Divide by 4, by 4, by 4, by 4. So here we get theta is equal to 90 divided by 4. 45, 22 and 0.5. Plus or minus the period n. Here theta is equal to negative 22.5 plus or minus the period n. Our b value is a value of 4. Our b value is a value of 4. So the period will be what, Isaac? $90n and $90n. Second one, inverse sine of 0. Clickety clack through. We take the inverse sine once again. Okay, hopefully you're getting used to what we having to do here. So the inverse sine of 0. Mia, what is it? 0. And then inverse sine, we have to do the second value.
Is that 180?
Huh?
Isn't it the supplement?
Supplement? What's the supplement of 0?
Or negative 90?
Negative or positive, does not matter. So we have 0 or 180 plus or minus the period n plus or minus the period n. Our b value is 1, so we have 360 n. So we have 4 general solutions here. 4 general solutions, which will give us values that would make this equation true. I won't ask for specifics. Rewrite as a sum or difference of sine and cosines of positive angles. Okay, I want to rewrite as a sum or difference. Right now we are in products. Things being multiplied together. So I want to take from products back to sums and differences. So I'm looking at the right hand side because all my right hand sides are products. So I want to take it from the right hand side over to the left hand side. So I'm looking for something on the right hand side that looks like 2 sine of something times the cosine of something. Of the top 4, which one has 2 sine cosine?
Sine A plus B.
Sine A plus, not, go ahead.
Sine A plus B plus the sine of A minus B.
Yeah, the very first one. If you look at the very first one on the right hand side, it has 2 sine A cosine B. That's what we have here. Here's my A. Here's my B. So let's take it back to the right hand or left hand side. So I'm going to take it from the right and just transfer it into my left. So I have sine of A plus B plus the sine of A minus B. Which is sine of 100 plus, oopsie, not plus. Yeah, plus the sine of negative 20. Now, my instructions tell us to make these all positive angles. Well, how do I make this a positive angle? Because I have a negative 20. Well, this is where the odd and even functions that we talked about last chapter comes into effect. The sine or the cosine of negative 30 would equal the cosine of 30. Try in your calculator. Take the cosine of 30, take the cosine of negative 30. You get equal values. So if I have the cosine of negative 30, I can make that the cosine of 30. I can just erase the negative sign. It's going to give you the same value. But this is an even function. This is an even function. Sines were odd. So if I take the sine of negative 30, this does not equal the sine of 30. But this will equal the negative sine of 30. These are opposite values. Odds means they're opposites. So what happens with my negative sign, and I can pull it out front. So this negative sign here can get pulled out front for your sine. So we have sine of 100 plus a negative sine of 20, or you can write that minus sine of 20. Rewrite as a product of the sine and cosine of positive angles. Now I want to deal with this as a product. We have sums and differences. So I'm looking at the right hand side. I want to transfer this to the left hand side, or I'm sorry, I have the left hand side, I want to transfer it to the right hand side. So I'm looking for one that deals with cosine plus a cosine. So look for one that says cosine x plus cosine y. There's your x and here's your y. Go to the right hand side, plug in for your x and y. to have 2 cosine 30 plus 50 divided by 2 times the cosine of 30 minus 50 divided by 2. It's the second one from the bottom. Not the bottom one, but the next one below the bottom. So now I clickety-clack through. What's 30 plus 50, 80 divided by 2? It's 110. Divided by 2, 55. Times the cosine of 30 minus 80, which is negative 50, divided by 2, negative 25. When I read, once again, want to make these positive angles. When I have the cosine, I can use my eraser postulate. The negative sign just goes away. In your homework for today, you have 3 sections of problems. I think this is your first section right here. I think this is your second section right here. Check to make sure. Nope, I was incorrect. This is your first section here. This is your second section here. And this is your third section right here. So you can refer back to these 3 sections or these 3 problems. What number do I be stopping at? 39? Don't worry about 39. You can stop at 27. Stop at problem number 27. So you have 3 to 27 multiples of 3. Okay, once again, your first section of problems is going to be very similar to this right here. Second section will be the last one. The third section will be this one right here. Okay, tomorrow we'll come in, we'll start combining everything together. Okay, we'll combine everything together in regards to the problem. Half angles, double angles, and sums and products formulas. I'm steering towards a quiz still on Friday. I may push it to Tuesday though. I'm just gonna see what the climate is as we go forward here this week. Because I'd like you to be able to do it here in class. I just want to make sure. I just want to see what the climate is. Who knows? Let's keep pushing forward. Look, for every day we're here, it's a blessing of the day. Questions?